So this presentation will be on concentration units. Our objectives: we will introduce concentration units, we will define molarity, and then we will calculate molarity of solutions. Specifically, we'll calculate with the molarity of solutions as well. Concentration is a measure of how much solute is dissolved in the solvent. There's a large variety of units to express this value. I've listed a lot of them here. This isn't even the full list. There's more than this. So why do we have so many different ways of expressing concentration? Because there are a large variety of reasons that you need to measure concentration. Parts per thousand, parts per million, parts per billion, parts per trillion are all used to measure pollutants in the atmosphere and in water. We use molarity and molality to measure things in lab because they're convenient concentration units for reactants. We use mass percent to determine an empirical formula. We use mole fraction for specific purposes. Each one of these has a wheelhouse that it sticks to, basically. But no matter what unit you use, the value in the numerator will always refer to the solute, and the denominator will refer to solvent or solution, depending on the unit. The most common units used to express concentration in chemistry labs is molarity or molality. We are going to focus on molarity. So what is molarity? Molarity is given by a capital M, not to be confused with mega, the prefix. Capital M by itself is molarity, and it stands for moles of solute over liters of solution. And this is important. Liters of solution, not liters of solvent, but liters of solution. So why is this so popular? What's going on there? See this nice piece of beautiful glassware to your left? This glassware is really accurate for given temperatures. Usually they are calibrated for room temp. As you increase the temperature, you actually increase the volume of liquids. So molarity is a temperature sensitive way of measuring concentration. Volumetric glassware is easy to use. It's another reason it's popular. And finally, why would we bother changing it if it's been working well for literally centuries? Not a joke. Centuries. You can look back in pictures from the 1800s, from the 1700s, and you will see something akin to this piece of glassware. So let's try some calculations. Calculate the molarity of a solution containing 2.5 grams of sodium chloride in 100 milliliter container. So we look back at our definition of molarity. It is moles of solute over liters of solution, which means that we need to convert from grams to moles, and we need to convert from milliliters to liters. So let's go ahead and do that. So we have 2.5 grams NaCl. And we're going to multiply by 1 mole over 58.44, which is the molecular weight or the molar mass. It's actually the formula weight of salt. That's going to give us 4.3 times 10 to the negative 2 moles NaCl. All right. Remember that we get our formula weight from the periodic table. We just look up the masses there. Now, when you're converting from milliliters to liters, there are 1,000 milliliters in a liter, and when we divide by 1,000, we move to the left 1, 2, 3 spaces. So this is going to be over 0.1000 liters. When we do that math, we come out with 4.3 times 10 to the negative 1 molar, that's how we say that, NaCl. Not too bad. Now let's calculate the mass of sodium chloride needed to make 250 milliliters of 1 molar NaCl. So again, we need to go from milliliters to liters. And when we multiply molarity by liters, we get moles. So we're going to take that 1.0 molar NaCl, and I'm going to write that in its base units. Well, not exactly base units, right? Because liters isn't a base unit, but you get the idea. The component units. And then I'm going to multiply by the volume of stuff. And I get the number of moles. So that is, there we go. We'll pretend we can read my handwriting really well. That's moles of Na.
Because she's using a mouse and it's hard to write with a mouse.
True story, Suze. Okay. Editorial comment provided by my daughter. All right, so we're going to start with that 0.25 moles NaCl. And we're going to take the same molar mass that we used before, 58.44. And when we're done, we round to sig figs because we started with 2 sig figs in our molarity, and we get 15 grams of sodium chloride. Okay, now the thing that will tend to mess you up when you're calculating with molarity is if you forget to convert from milliliters to liters. The other thing that will tend to mess you up when you're dealing with molarity is if you don't put the units, and that includes what the chemical species is. So when you're doing your chemistry here, you always need to include what units you're working in. And molarity is moles per liter. So here we go. There are lots of different units to convey concentration, but the most used in lab is molarity, given by capital M, and it is moles of solute over liters of solution.